last lecture, we will discuss about our case number 8, which is when the UDL is acting on propped cantilever beam. Okay, so students, let us revise. So, in the last lecture, we will discuss about this case number 8, in which this question is asked in GTU. Okay, so this question is asked like find the collapse load or plastic moment for propped cantilever beam carrying a UDL capital W kilonewton throughout the span. Okay, now this question is asked for GTU point of view for 7 marks, and this question is asked in other way like find the collapse load or plastic moment for propped cantilever beam carrying a UDL. Okay, and you all know that what is the unit of UDL? The unit of UDL is kilonewton per meter. But in this question, it is clearly mentioned that UDL capital W kilonewton. It means in this question, your UDL is converted with point load by multiplying some length. Okay, so this question asked in GTU for two way. Okay, in one type of question it is considered as small w kilonewton per meter, and in other way it is capital W kilonewton. Okay, so this is the very most important case for GTU point of view. Okay, so in this chapter we will discuss about total 8 cases, in which there are 5 cases for point load and 3 cases of UDL. Now we are moving further to some examples. Okay, and what is the difference between these basic theories and examples? So it is, you can see that in all the 8 cases we are discussing about only one span. Okay, but whenever you have to design any component or any beam, then there is not only one span but it is a continuous span. Okay, so continuous beam is called as if the beam having two or more span, then it is called as continuous beam. Okay, so now we are moving further to the examples of continuous beam. Okay, and all the methods are remain same as discussed in case number 1 to 8. Okay, so your first question is find out the value of capital W at collapse condition for the continuous beam as shown in figure. Okay, so students, you can see that in this figure there is two span. First span is AB and second span is BC. Now you can see that for span AB, the load capital W is acting at a distance of 2 by 3L from left support and L by 3, or it is also called as 1 by 3 of L from right support. Okay, so first of all we are discussing about our span number 1. So you can see that consider a mechanism of span AB. Okay, now it is already discussed that whenever you have to calculate any examples, then your step number 1, which is number of redundancy, and step number 2, which is number of plastic moment, is not required. So whenever you have to solve any example, you have to move out your step number 3, which is kinematic methods. So now we are moving further to directly step number 3, which is kinematic methods. So in kinematic method, first of all we have to find out deflection shapes. Okay, so now you can see that your point load is acting at some distance, not at the center. Okay, so this distance is 2 by 3L and this distance is 1 by 3L, or it is also called as L by 3. Okay, now your point load is acting at L by 3 from right support. So if your distance is difference, then your deflection angle is also difference. Okay, so you can see that this is your theta, this is your theta 1, and at the center the total angle is theta plus theta 1. Okay, now you can see that this is 2 by 3L and this distance is L by 3. So this point is intersect at this point on one and only if this both the deflection value having same. So there is some relation between theta and theta 1. So it is 2 by 3 L into theta is equal to 1 by 3 L into theta 1. So your relation between theta 1 and theta, so it is theta 1 is equal to 2 theta. Now your external work done, so it is load into deflection under the point of load. So you can see that this load is now considered as your collapse load. So it is WC into 2 by 3L of theta. So this is your external work done. Now your internal work done, it means you can see that this is support and this support is either hinge support or it is roller support because it restrains the vertical force. Okay, now you can see that this simple support doesn't restrain moment. Okay, so at this point your MP is equal to 0. Now this point restrain the moment, that's why we are writing over here it is MP, and you all know that your intermediate support is considered as fixed support, and you all know that your fixed support is restraint moment. So at this point the value it is MP. Now your total internal work done at this point is equal to 0, at this point is equal to MP into theta plus theta 1, and at this point it is MP into theta 1. Now your span AB is balanced once and only if your external work is equal to internal work. Okay, so for equate both the values, your both the terms in the same value. Okay, so you can see that your external work done is in the form of theta, so you have to convert your theta 1 to theta. Okay, so it is MP theta plus theta 1 at this point, and at this point it is MP theta 1. Now we have one relation which is theta 1 is equal to 2 theta. So now we have to put out our theta 1 value is equal to 2 theta, and we will get our answer 5 MP theta. Now you can see that your external work is in the form of theta and your internal work done is also in the form of theta. Okay, so now if your both the term is in the form of theta, so now you have to equate the value, and in the question it is clearly mentioned that find out the value of W. So that's why we have to make collapse load is our subject. So WC is equal to 7.5 MP by L. Okay, so this is the span AB. Now we are moving further to the calculation of span BC. So for span BC, this support is a fixed support because it is intermediate support. So this point is takes moment. This point is also takes moment, and this is your simple support. That's why this is not taking any moments. So its deflection shape like this. So you can see that this W is considered as now your WC. This point is your intermediate support, and that's why MP is written over here. At the point of load, it is compulsory to take moment, so MP is written over here, and this support is your simple support, and you all know that your simple support doesn't take any moments. That's why there is no any clarification regarding MP over here. Okay. Now we are moving further to the consideration of mechanism for span BC. So there is one relation which is equal to A theta is equal to B theta 1. So 1 by 3 into L theta is equal to 2 by 3 of L into theta 1. Now your theta 1 is equal to 1 by 2 into theta. Okay. So there is a relationship between theta 1 and theta. Now all the calculations remain same, like external work done is equal to load into deflection under the point of load. So it is WC into 1 by 3 of L into theta. Now your internal work done is MP theta. At this point it is MP theta plus theta 1, and at this point it is 0. So now we are moving further and convert your theta 1 form to theta form with putting your theta 1 is equal to 1 by 2 theta. Okay. So after all the calculation, your internal work done is 5 by 2 MP theta. Okay. Now you can see that your external work done is in the form of theta and your internal work done is similar in the form of theta. It means if your both the work done is in the same form, then you have to equalize both the values and make WC is your subject, because in the question it is clearly mentioned that find out the value of W. Okay, so this is your second answer. Now, which answer is more effective to design whole continuous beam? So it is clearly mentioned that smaller value of two values. Okay, so whenever you have to find out WC, then you have to consider smaller value is your maximum value, and that's why for smaller value you have to design for your beam. So your final answer is WC is equal to 7.5 MP by L, because your both the answer remain same. So your smaller value is not possible. So that your value is equal to your smaller value. Okay. So students, this is the end of your example number 1. Now we are moving further to our example number 2, in which it is clearly mentioned that find out the plastic moment capacity. It means MP for the figure given below. So you can see that this is the figure given in your book, or it is same figure is given in your presentation. Okay. So this is your fixed support A junction, this is your intermediate support, this is B junction, and this is your simple support, so this is C junction. Now all the calculations remain same. So first of all we are moving further to the calculation of span AB. So you can see that on span AB there is a 60 kilonewton load is acting at a distance of 4 meter from left support, and for span BC the 50 kilonewton load is acting exactly at the center, because 3 meter from left side and 3 meter from right side. Okay, so now first of all we are moving further to the calculation of span AB. So the distance is not remain same, because on the left side the distance is A, which is equal to 4, and on right side the distance is 1, which is equal to B. Now whenever your distance A and B is different, so there is one relation between theta and theta 1. So it is 4 theta is equal to theta 1. That's why your theta 1 is equal to 4 theta. Now your external work done is equal to load into deflection under the point of load. So it is 60 into 4 theta, which is equal to 240 theta. Now your internal work done. So you can see that this is your fixed support, and fixed support is takes the moment. So at this point it is MP into theta. at under the point of load, it is always takes moment. So at this point, it is MP into theta plus theta 1, and your B support is your intermediate support, and intermediate support is considered as your fixed support. That's why this point is also takes moment. Okay, so your internal work done equation is MP theta, it is at A point, MP theta plus theta 1, it is under the point of load, and this is MP theta 1, it is at the B point. Okay, now you can see that your internal work done is in the form of theta and theta 1. So you have to convert the value of theta 1 to theta by putting theta 1 is equal to 4 theta. And after calculating all the calculation, your internal work done is equal to 10 MP theta. Now your external work done is equal to 240 theta, and your internal work done is equal to 10 MP theta. Now with solving this equation, your answer is MP is equal to 24 kilonewton into meter. Okay, so this is your first answer. Now we are moving further to the second span, which is span BC. So you can see that on span BC, a 50 kilonewton load is acting exactly at the center. So you can see that it is the deflection shape like this. So your external work done is equal to 50 into deflection under the point of load. So this is 3 theta, and this is also 3 theta because your point load is acting exactly at the center. So 50 into 3 theta, which is equal to 150 theta. Now your internal work done. So you can see that this is point B, and your point B is intermediate support, and your intermediate support is considered as fixed support, and your fixed support is takes moment. So MP into theta at this point. Now under the point of load, it always takes moment, so it is MP, but at this point our total angle is theta plus theta, which is equal to 2 theta. So this is MP theta plus theta, and at this point, at C point, your support is simple support, and you all know that your simple support don't take any moments. Okay, so after calculating all the values, your internal work done is 3 MP theta. Now your external work done is in the form of theta, and internal work done is also in the form of theta. Okay, now after putting all this value, we will get and we will equalize both the values. So you can see that 150 theta is equal to 3 MP theta. So after solving this equation, your answer of MP is 50 kilonewton into meter. So this is your answer number 2. Now the major difference between example number 1 and example number 2 is that whenever in the question it is clearly mentioned that find out W or the collapse load, then you have to consider smaller value of of equation number 1 and equation number 2. But whenever you have to ask that find out plastic moment, then you have to consider as maximum moment. Okay, so you can see that larger of these two values is considered as plastic moment. So you can see that your first answer is 24 kilonewton into meter, and your second answer is 50 kilonewton into meter. So your maximum answer is 50 kilonewton into meter, and that's why this is the value of your plastic moment, and you have to design your whole beam for 50 kilonewton into meter. Okay, so students, this is the end of today's session. Thank you.